So this presentation is going to be on the statistical measures we can use for establishing reliability. So let's start with reviewing the theory around reliability. And it's pretty simple. It's just the equation of an observed score is comprised of the true component plus or minus the error component. Let's talk a little bit about reliability coefficient now. So the equation for that reliability coefficient is the true variance over the true variance plus the error variance. Or another way of looking at it is the true variance over the total variance, or the total variance minus the error variance over the total variance. So any of those equations will work. So an example is the interclass correlation coefficient. It's a reliability coefficient, and it ranges from a 0 to 1, and it can be calculated using the variance estimates obtained through your ANOVA, the analysis of variance analysis that you may have conducted. It is generalizable, and it can be useful in a number of ways. One way it's used frequently is assessing the reliability among two or more ratings. So if you have two different instruments to measure a similar thing, you can run the interclass correlations and see how much agreement there is, how much of a reliability coefficient, and certainly the more agreement, the higher, closer to 1 you are. It does not require the same number of raters for each subject, and it can be used with ordinal data if the intervals between the measurements are assumed to be equal. The models of the interclass correlation can be either random or fixed effects. So model 1, each subject is assessed by a different set of K raters, random effects. Model 2 is each subject is assessed by the same set of raters, that's a random effects. And model 3, each subject is assessed by the same set of raters, but the raters represent the only raters of interest, and that's a fixed effect. The interclass correlation is based on ANOVA. And the inter-rater reliability study, the rater is the independent variable. The intra-rater reliability study, the trial is the independent variable. Now in this table, it talks about the intraclass correlation coefficient and how to interpret those values. So the strength of agreement is considered almost perfect if it's greater than a 0.8. It's considered strong if it's 0.7 to 0.8. It's considered moderate if it's 0.5 to 0.6, fair if it's 0.3 to 0.4, and poor if it's 0.2 or lower. So agreement means the percent agreement for categorical scales. The change agreement is the kappa statistic. And a weighted kappa is when the greater weight is applied to some disagreements. If you think some areas are more important than others, you may use the weighted kappa. Now, internal consistency is measured with the Cronbach alpha, and it's the correlation among individual items and the total score. The response stability is the standard error of measurement, and it's the standard deviation of the measurement errors and your confidence interval. So it's a coefficient of variation and a standard deviation of responses. And there's a method error. There's the discrepancy between two sets of repeated scores. The reliability between forms can also be established, and you're establishing the reliability when alternate forms of an instrument are used. So you have the correlation coefficient, or a paired t-test, that can help you look at these and the limits of agreement. And remember, the most commonly applied statistical index for internal consistency is the Cronbach's alpha.